The square root of negative 49. All right. So the square root of negative 49 is an imaginary number or a complex number, something we have been covering in class. So what you want to do is you want to rewrite this problem. So you're going to take the opposite of this negative number and you're going to do the principal root of a positive 49 times the square root or the principal square root of a negative 1. All right. Now the reason why I chose these two numbers is because you want to make sure that you do not change the actual problem. If I go back and multiply the square root of 49 times the square root of negative 1, it's going to give me the square root of negative 49. So now I'm going to simplify both of these separately. So the square root of 49, or the principal square root of 49, is equal to 7. And then the principal square root of negative 1, or the square root of negative 1, is going to be equal to I. All right? Basically, all you're going to do is just put these two together to where you don't have this multiplication symbol in the middle because you don't need it. 7 times I is simply 7I. So your answer for this one, the square root of a negative 49, is equal to 7I. Okay? If you need to pause the video, you're welcome to do so. Rewind, fast forward, whatever it is you need to do. Let's go ahead and erase this one. All right, so let's try another example. And this time, we're going to make sure that we use something where it's not a perfect square once you simplify using the second step. So I'm going to give you guys the square root of negative 48. So again, you want to rewrite this problem to where you don't change it, but you can go ahead and break it into a real part and an imaginary part. So I'm going to basically do the opposite again. So the opposite of this square root of a negative 48 is the principal root of a positive 48 times the square root of negative 1. So if I go back and multiply these two, I'm going to get the original problem. It did not change. So I'm going to simplify this real part first. And this is a real part because you can find the square root of a positive number, okay? Now this won't give you a whole number because it's not a perfect square, but it will give you a solution to where you're going to have a real answer. All right, so before you do this, guys, in class, like I told you, want to come over here to the right or to the left, and you want to list the factors of 48. All right, so we know 1 times 48 equals 48, so 1 and 48 are factors. 2 times 24 gives you 48, so those two are factors. 3 times 16 is going to give you 48, so 3 and 16 are factors. We have 4 times 12 is 48, so those are factors as well. And last but not least, we have 6 times 8. So the factors of 48, I'm going to rewrite those up here in order. Make a U shape. Yoop. Is 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. So now you got to ask yourself, which one of those factors is the perfect square? Well, what I like about this problem, this example, is that 4 is a perfect square and 16 is a perfect square. You want to select the one that has the largest perfect square. So 16 is bigger than 4, so you're going to use 16. So what number can you multiply 16 by to get 48? 3. That's why it's good to write it side by side. So we're going to do the square root of 16 times the square root of 3. I'm not changing the problem. 16 times 3 is still 48. Bring down the square root of negative 1. If I multiply all three of these, I'm still going to have the square root of negative 48. So basically, we're just simplifying this, okay? We're simplifying it like if you were doing 4/8. If you was to try to simplify that in the simplest form, this would be 1/2. So a lot of people would say, well, Ms. Smith, why this can't be 48I? It can, but it won't be in the simplest form. So you got to go ahead and do it to where you can no longer solve it. All right, so now that we have simplified the square root of 48 with the square root of 16 times the square root of 3 and brought down the square root of negative 1, we're going to go ahead and solve. So the square root of 16 is 4. The square root of 3 is a non-perfect square, so you just leave it as the square root of 3. And we know that the square root of negative 1 is always equal to I. All right, so you always want to take that constant and the imaginary symbol I, and you're going to put it together. So there's 4I. And then just bring down the square root of 3. As you can see, I no longer put the multiplication symbols in between, but I am multiplying, okay? So that's the answer for that one. Yay! Woohoo! All right. Again, guys, if you need to pause this video, please do so. Go back and look at whatever you missed. Now we're going to do powers of I. All right. So with the powers of I, there are some basic rules that you guys have to remember. So let me get my sheet so we can look at this. So when you are simplifying the powers of I, remember you're going to divide by the exponent 4, and you're going to use the rules where it says if you have a remainder 0, the answer is 1, remainder 1, the answer is I, the remainder 2, the answer is -1, the remainder 3, the answer is -I. So I'm going to give you a couple examples. So the first one is going to be I to the second power. Just to show you guys, I already know we listed the first 4 solutions of I, but I just want to do it anyways to show you guys what's going on. All right, so remember, guys, what you're going to do is you're going to take that exponent and you're going to divide it by 4. All right, so this is just like saying 2 divided by 4, where the 4 is on the outside and the 2 is going to be on the inside. Divisor on the outside, dividend inside, okay? 4 goes into 2 0 times. If you subtract, you're going to get a remainder of 2. R stands for remainder. Because I have a remainder of 2, if you go back to your photo bowl, you're going to see that when you have a remainder of 2, your answer is a -1. So I squared is equal to -1. Okay? Moving on to another example. Let's do I to 16. What does that equal? So again, you're going to take the exponent and you're going to divide it by 4. So your 4 is always going to be on the bottom. When you rewrite using that little radical division symbol, it's not really a radical symbol, it's a division symbol, so don't get it mixed up. That's why I did the little curve. So you're going to put that symbol, your divisor is going to be 4, your dividend is going to be 16. 4 goes into 16 4 times. 4 times 16 is going to give you 4 times 4 is 16, so you're going to go ahead and put your 16 there. Subtract, your remainder is 0. And remember, when your remainder is 0, your answer is going to be 1. Absolutely. All right, let's do a big number. So we're going to do I to the power of 576. What does that equal? All right, so again, you're going to take that exponent, you're going to divide it by 4. 4 is going to be your divisor, 576 is your dividend. 4 goes into 5 one time. 4 times 1 is 4. Go ahead and put your 4 there. Go subtract 5 minus 4, which is 1. Bring down your 7. 4 goes into 17. 4 times, it's going to give you 16. 4 times 4 is 16. Subtract. Once you subtract, you get 1. Bring it on down and bring it on back. Divide. 4 goes into 16 4 times. Multiply. 4 times 4 is 16. Subtract. Your remainder is 0. Bring it on down and bring it on back. Divide, multiply, and subtract. Woo! All right, so since your remainder is 0, your answer is going to be 1. All right, so I'm going to keep that up there and I'm going to just add like 2 little digits to it. No, I'm not. I'm going to make it even bigger. So we're going to do 3,712. Ooh. Now, I'm going to change this to a 4, because I can do that, okay? So again, you're going to take the 3,714 divided by 4. 4 is your divisor, 3,714 is your dividend. 4 goes into 3, 0 times. Subtract, you get 3. You're going to bring down your 7. 4 goes into 37, 9 times. It's going to give us 36. Subtract, you get 1. Bring down this 1. 4 goes into 11. 2 times, guys. That's going to give you 8. 11 minus 8 is 3. Bring down your 4. 4 goes into 34 8 times. 32. And your remainder is 2. And what is that going to be equal to? If your remainder is 2, the answer is going to be -1.